My dear students, in the previous video, we proved two theorems, the uniqueness of identity and the uniqueness of inverse. These two theorems we have proved in the previous video. Now I am going to start the exercise 12.1. Exercise 12.1. So in this video I am going to start the exercise 12.1. The problems in the exercise. First problem. Determine whether star is a binary operation on the sets given below. Determine whether star is a binary operation. Star is a binary operation on the sets given below. On the sets given. First problem. For every A comma B belongs to R, real number set R, the operation star is defined by A star B equal to A into mod B on R. In the set of real numbers R, we have to check whether the binary operation star defined by the two elements belonging to the set R, A comma B, such that A star B equal to A into mod of B. A is an element of the real number set R and B is also in the real number set R. Real number includes all the positive, negative real numbers. So, A belongs to R. There is nothing difficult in this. Straight away we can say A belongs to R. Modulus of B belongs to R. Whether B is positive or negative, mod B is positive. If B is negative, mod of B is also positive. Mod B is also belonging to R. Both B is positive or negative. If B is positive or negative, if B is positive or negative, mod of B belongs to R. Therefore, the product A into mod B, therefore A into mod B is also belongs to R. Therefore, A star B is well defined on R. Therefore, star is a binary operation on R. Hence, star is a binary operation. Star is a binary operation on R. That's all the problem. First problem. If the star is defined by A star B equal to A into mod B, A is in the real number set. Modulus of B is also in the real number set if B is positive or negative. Therefore, A into B is also belongs to R. Therefore, star is well defined. Hence, the binary operation is defined on the star is the binary operation on the given set R for this given condition. A star B equal to A into mod B. Now, second problem. Second problem is subdivision. Second subdivision, the first problem. A star B equal to minimum of A comma B. A star B equal to minimum of A comma B on the set A equal to on the set A is given by 1, 2, 3, 4, 5, given by 1 to 5. A star B is given by minimum of A comma B. We say that A and B, A comma B belongs to A. For every A comma B belongs to A. Minimum of A comma B means minimum of A comma B is either A or B. Minimum of A comma B is either A or B. Minimum of A comma B is either A or B. For example, if A is 1 comma 5 belongs to A, minimum of 1 comma 5 is equal to 1, because after 1 comma 5, 1 is the minimum value. Like that, for any two elements, 4 comma 3 belongs to A. Minimum of 4 comma 3 is 3 is the minimum. Like that, every element in the set A, using the condition minimum of A comma B, A star B is minimum of A comma B. Here, 1 comma 5 belongs to A, minimum of, this is, you can write it as 1 star 5 is equal to minimum of 1 comma 5, that is equal to 1, like that you are right. Similarly, 4 comma 3 belongs to A, 4 star 3, according to the definition, 4 star 3 equal to minimum of 4 comma 3, which is equal to 3. Like that, any element belongs to A. Minimum of A comma B is again A. Therefore, star is binary operation. Star is binary operation on A. For every A comma B belongs to A, minimum of A comma B is either A or B. Now, using this rule, any element in this set A, minimum of those two elements becomes, we will take the minimum value. Therefore, the star is binary on A. Now, third subdivision in the problem, first problem. Third problem is for every A comma B belongs to the real number set R. For every A comma B belongs to the real number set R, A star B is defined by A into square root of B on the set R. A into square root of B on the set R. Is it binary on the set R? Is the operation star is binary on the set R? We have to return it. See, A is a real number, A belongs to R, and B is also belongs to R. If B is negative number, negative real number. So, say for example, minus B. If B is negative, root of B does not belong to R. If B is negative, root of B does not belong to R. That means, if B is negative, say for example, minus 7, root of minus 7. It's not a real number. It does not belong to the real number R. Therefore, A into root B is that if root of B, if B is negative, root of B is not in R. Say for example, negative real numbers are not in R. Square root of negative real numbers. Square root of negative real numbers are not belongs to the set R. Therefore, this star A star B equal to A comma A root B for this problem, star is not a binary operation. Not a binary operation on the set R. solve this problem. So first two problems, star is binary on the given set, but in this problem, the given star is not binary on the given set of, because root of b is negative, it is not in the set of. That's all about the first problem. Next, let us go to solve the second problem. In the first problem, there are three subdivisions in the exercise. First problem, these three subdivisions are there. Now let us go to the second sum. Second problem. On a set Z, on the set of integer Z on Z, the circle cross, the binary operation is called a circle cross, circle in the across. This is the binary operation. Circle cross we can call it, so we can call it this operation as circle cross. On Z, circle cross is defined by M circle cross n equal to m power n plus n power n. M into m circle cross n is equal to m power n plus n power m. It is given for all m comma n belongs to the set of integers. Check whether this operation is binary or not on the set Z. Check whether the circle cross is binary or not. The definition of circle cross is this: for every m comma n belongs to Z, m circle n is m power n plus n power n, m power n plus n power n. Suppose since it is a set of integers, negative integers is also there. For example, suppose this n equal to, suppose n equal to negative integer minus p. We can say n equal to minus p. What is m power n? M power n is m power minus p. In this case, negative power is 1 by m power p. M power minus p is 1 by m power p. This is a fraction. It is not in Z. Fractional numbers are not a rational number. It's a fraction. It is not in the set of integers. Therefore, m circle cross n, m power n plus n power m, if m is negative or m is negative, whatever it may be, if you take m is negative, it's also a rational number. It's not in the set of integers. Therefore, circle cross is not a binary operation. Not a binary operation on Z. This is second problem. Third one. If p is negative, it becomes m power minus p is 1 by m power p. It is a fraction. It is not in Z. Therefore, circle cross is not a binary operation on the set Z under the operation circle cross. The third problem. Let star as a binary operation be defined on the set of real numbers R by, defined by A star B equal to A plus B plus AB minus 7. Let star be a binary operation on the set of real numbers. It is defined by A star B equal to A plus B plus AB minus 7 for all A comma B belongs to set of R. If it is the definition of star, check whether this is a binary operation is binary on the set of R. Check whether, verify whether it is binary on R, and also find and also find the value of 3 star minus 7 by 15. 3 star minus 7 by 15. And also find 3 star minus 7 by 15 under this definition. Since A comma B belongs to R, addition and minus subtractions are also binary operations on R. A comma B belongs to R and addition and subtractions are binary on R. Therefore, AB is also belongs to R, minus 7 is also belongs to R, A belongs to R, B belongs to R, AB is also belongs to R, minus 7 is also belongs to R, A number 6, negative number 6 also there. Therefore, A star B equal to A plus B plus AB minus 7, or sum of all these elements are also belongs to R. Therefore, the given star is binary. Star is a binary operation on R. First part. We can define star is a binary operation on R. Binary operation on R. And also they are asked you to find out 3 star minus 7 by 15. You will find out the value. This is the first part. Star is binary operation on R because all the elements belong to the set R. Hence, the sum is also belongs to R. Hence, choice is binary. Now, we have to find out the value of 3 star minus 7 by 15. By definition, this is A and this is B. A star B is A plus B. A plus B plus AB, A 3, B minus 7 by 15, A plus B plus A into B minus 7. Instead of A, you can replace 3 and instead of B, you can write minus 7 by 15. A plus B plus A into B minus 7 by definition. This is 3 minus 7 by 15 minus 3 sevens are 21 by 15 minus 7. You will take LCM for all these things. That's 15. 3 15s are 45. 1 15, 1 7. 1 15, 1 into 21. Minus 15 sevens are 105. So this is positive number 45. Negatives are 5, 6, 8, 13. 5 plus 1, 6, 6 plus 7, 13, 1, 1 plus 2, 3, and 133 by 15. This is minus 133 plus 45 is minus 15 minus 5, 13 minus 5, 8, 88 by 15. So the value of 3 star minus 7 by 15 is minus 88 by 15. That is the answer for the operation of these two elements. Minus 88 by 15. That's all about the problem 3. And we will continue in the fourth problem in the next video. Thank you.